And today, we want to talk about a particular part of Meteor 1.5. You guys may have heard that Meteor 1.5 is all about production application performance, and part of that is reducing your bundle size and using fewer libraries by using dynamic imports, also sometimes called code splitting. But a really important part of that is understanding what parts of your app you need to split and how large those different bundles are, and that's what the meat of that will be today. So today we're going to get a bit of a window into our friend Jesse, who actually spends most of his time in Helsinki in Finland, and he comes down to San Francisco once in a while, and he unfortunately couldn't make it to be here today, but he's created a really great demonstration for us, and I'm going to introduce that, and then also follow up with that and answer any questions you guys might have.
So I do truly wish I could be giving this talk in San Francisco. However, I've opted instead to wear all Meteor apparel, and I hope you'll appreciate my spirit. Furthermore, unless my schedule has gone completely awry, I should be asleep when you're watching this, as it will be about 4 in the morning. This talk will be a continuing episode in the Meteor 1.5 saga. I'm happy to say that the first release candidate of Meteor 1.5 RC0 came out yesterday, and that's a pretty exciting milestone for us here. If you haven't been following the exciting developments happening on Meteor 1.5, that's okay. I've been quite preoccupied with non-Meteor 1.5 tasks myself, but rest assured, Ben Newman has been hard at work seeing it through to fruition. If you're interested in the gritty details, the Meteor 1.5 pull request is the best place to see how the release has evolved and a lot of the considerations which have gone into it. In short, though, if you've seen the Meteor roadmap, you'll know that improving client-side application startup time is the main goal of Meteor 1.5. And the headliner for Meteor 1.5 is the dynamic import statement. If you haven't already watched Ben's talk about dynamic imports from the last meetup and on the Meteor blog, it's certainly worth watching, as one of the takeaways from that talk is the realization that it's already possible to defer the initial execution time of various components by changing top-level imports to nested imports. Additionally, Ben showed that with dynamic imports in Meteor 1.5, developers can remove the digital weight of components which are not immediately needed from the initial download. They can then decide to either not retrieve those components at all or defer their retrieval until a more opportune time. The initial download of your application's code is what we refer to as the initial client bundle. So I'm going to talk about analyzing that bundle and show how critical the data from that analysis will be for Meteor 1.5. I've titled this talk MOUS, Modules of Unusual Size, which I hope at least one Princess Bride fan out there will appreciate. In this talk, I intend to show you that modules of unusual size might live in your project and also give you an understanding of the bundles which clients are downloading. And most importantly, show how a new feature we've just built for Meteor 1.5 will make it easier for you to find them. Now first, what kind of bundles are there? Well, there's different kinds of bundles for different types of code. For example, CSS and JavaScript are each packaged in their own bundle. And of course, there are server-side bundles too. There's certainly room for discussion for server-side bundles, and importing CSS files dynamically in the client is certainly possible as well. But for now, we'll focus on the initial JavaScript bundle for the client. To make that first load as quick as possible, we should be trying to make the bundle as lean as possible. Therefore, it's really important to know what's going into this initial client bundle. This is especially important in Meteor 1.5 as we start to make considerations about what can be changed into a dynamic import. In other words, what could wait and doesn't need to be there at first load. Now, it might be tempting to change everything in your application to a dynamic import, but dynamic imports do have a cost associated with them, such as round trips to the server, cache checks, etc. So I'll certainly suggest that you avoid that temptation until you have data to back it up. For example, if you have some code that is always executed on every visit and that code is relatively small, it may not make sense to add the overhead of a dynamic import when it would be better off in the initial bundle. You might ask, why would my initial client bundle be so large? Well, in everyday development, we use many external dependencies to make development easier. These modules all come with a particular feature set, and depending on that feature set, the package may have significant complexity in the form of code. For dependencies which should only be on the server, it's really not too big of a deal. You certainly don't want to install more than necessary, but the real concern comes into play when it comes time to send those dependencies over the wire to the client. I'm going to show you how to see what it is that you're sending to the client. For starters, I'm going to create a basic Meteor application and fire it up. And for this app, I'm going to use Meteor 1.5 RC0, which just came out. And while that runs, let's take a minute to think about some of the larger dependencies you might be familiar with and possibly even use in your application. D3 is a very popular library for creating charts, etc. Faker, a good way to generate data for a variety of reasons. Highlight.js, a fantastic way to add syntax highlighting to code. The AWS SDK, really good for communicating with all the various Amazon Web Services. And Lodash. Well, you probably know Lodash as it's the most dependent on NPM package on NPM.js, and it's insanely useful. Now, this doesn't necessarily mean that these packages are at fault in any way. In fact, quite the contrary. Powerful packages can be easily misused by complete accident. Oftentimes, they have hundreds of features, and you only need 1 or 5. For example, if you were to install Google's Material Design Icons package, you'd find that you just installed 356 megabytes of really cool icons into your application's node modules directory, but maybe you only wanted 1 of them. So let's go ahead and look at the Meteor application I just started. I'll go over to my web browser, where I already have my localhost port 3000 open, along with Chrome Developer Tools, which I have on the Network tab, and furthermore, I've filtered it down to just JavaScript. If I go ahead and sort this list, you'll notice there's a lot of individual files being sent over the wire. This is because in development mode, Meteor avoids the costly task of combining and minifying files in an effort to reload as quickly as possible and allow you to continue on your way. You're running on localhost with no network latency, so everything still happens quickly. However, because the minification process doesn't take place in development, the sizes you see here are the full sources of the included dependencies with comments, whitespace, and a lot of additional data. You can get a rough idea of what's taking up space by looking at these 2 very important numbers. The top number is the compressed size. The bottom number is the size of the actual content, or uncompressed size. So by default, gzip compresses everything between the server and the client, and we get some real benefit there. You can see the jQuery is taking up 1.2 megabytes uncompressed, and the modules.js below that is taking up an even 1 megabyte. Let's get our base project size down a bit before proceeding. Since we've just started, instead of modifying this application, I'll just create a new app. Now, there are different options you can pass to Meteor Create, which affect the way that the app is created, and we can see those options by running Meteor Create --help, but as you can see explained here, one of those options is Meteor Create --bear. So I'll just go ahead and use that. If you're not familiar with the --bear flag, it essentially creates a completely empty Meteor project instead of having the default Blaze templates and folder structure. There's also a --full flag, which creates a more complex scaffolded application on par with the Meteor Guide recommendations, but we're going for almost empty here. Now, thanks to a recent change in Meteor 1.5, an app created with --bear no longer includes the Blaze HTML templates package, instead opting for static HTML, which is a configuration preferred by non-Blaze applications. Now that that's running, I'll go back to my browser and reload. A quick resort there just to make sure. Great, jQuery is no longer included. So the top size contender is now modules.js. Now, the module's name itself comes from the name of the Meteor package responsible for supporting npm dependencies, and this is something which first surfaced in Meteor 1.3. So the way this works is that all the node module files which you Meteor npm install in your application and are used by the client are packaged up into this one modules.js package. In fact, if we take a peek inside this modules.js file, we'll see that there is a rough concatenation of all the node modules that the client actually uses, and the format is one which the module loader can consume. I'm going to install a bunch of big dependencies into my Meteor app and try to make it unreasonably large, especially for how simple it is, because it's just a blank page, right? Well, this shouldn't be too hard. I'll go ahead and sneak ESLint in there at the end as well, because I want to lint my code, though I probably only wanted to do that in development, which would have been done with the --save-dev option. But I'm going quickly here, and maybe I made a mistake or three. Now, let's take a look at the damage I've done by using a few relatively basic commands. I can run tree-sh on my node modules if you have the tree command installed. And wow, look at all those files. 999 directories. If you don't have tree, you could try something like ls-lar. Yep, lots of files there as well. And du-c is a good way to see the total size of your node modules directory. If I add the h, we can see that it's 49 megabytes. I want to first show you that Meteor isn't silly about this. You can install many dependencies into your project, and if Meteor's import scanner doesn't detect that you've used them, it won't include them when linking your project and building the initial client bundle. If I reload my DevTools, it's still 1 megabyte. And that's correct. It shouldn't have grown because none of the new dependencies I've just added have been actually used with an import or require statement. Now, I'm going to go ahead and keep being kind of reckless here for the sake of this demo, but it's very important to point out that something like what I'm doing could very easily happen in a larger project with a lot of cross dependencies. I'll create an imports library.js file to house this list of dependencies that I want to use in one single place. And I'll go ahead and create a server main.js entry point, and I'll go ahead and add an imports/library.js because for the reason I want all of these on the server. Again, I'll look at the DevTools, and it's still 1 megabyte. Great. So adding all that weight on the server doesn't affect the client, which is the way it should be. Let's go ahead and create a client entry point now. Now, maybe I want to use Faker to generate fake latitude and longitude data. But I'm not really paying attention, or I'm just not aware. So I'm going to go ahead and do the same thing I did on the server, which is import imports library.js. OK, back to DevTools. Oh, wow, 24 megabytes. We've done some damage. But the compressed size is still 2.1 megabytes, so a pretty substantial savings there by using compression. Now let's take a look at the modules.js source again, and let's search for, say, Faker. Because that's what we wanted after all, right? OK, yeah, it's in there now, but let's see. My browser's not behaving very well with this 24 megabyte file, so I'm just going to go ahead and close it. It's pretty safe to assume that highlight.js is in there as well. Things would probably be greatly improved if the files were minified and those long variable names and white space and comments were all removed. But that happens in production normally. And again, let's remember minified and gzipped numbers are really the metrics which are the most telling and matter in the wild when the bundle needs to be shipped over the wire to the client. Let's dig into that a bit more. But first, let's take a peek inside of the already generated Meteor bundle for this application. If we go into .meteor/local build programs web.browser and do an ls, or really an ls-lar for recursive, we'll see all the files that we saw in DevTools that are being shipped to the client. Now, I'm going to restart Meteor with a special -- production option. If we take a look at Meteor run -- help, we'll see that this simulates production mode by minifying and bundling CSS and JS files. So this is not the way you should be running Meteor in production by any means. This simply causes a normal Meteor run to do the full, more costly minification, bundling each time you save a file. This is great for determining the benefits of each change, but it's a little bit slower. So now, once this starts up, we'll go into the DevTools and reload, and we can see that there's only one single file now with this file name, which is a computed SHA hash based on the contents of the file. And most importantly, the file size is now 912 kilobytes fully compressed and 3.1 megabytes uncompressed. Still pretty big, but a big improvement. If we click on it, we'll see that the contents are quite jumbled and difficult to read, and all of our verbose variable names and the white space is mostly gone. Now I'm going to show you some new output, which is available in Meteor 1.5, which will enable us to start getting real metrics about what's in this bundle and what we're shipping to our clients in production. If we go back into the Meteor local build programs web.browser directory, which we looked in a minute ago, we'll see that there's now just a few files in here. There's a hash.js file, which matches up with the name that we saw in the DevTools, but there's also a hash.stats.json file. Let's go ahead and look at that file. All right, we can see that this file has a tree showing the minified bytes by package, as well as the total minified bytes and the total minified gzip bytes for the contents of this bundle. And the byte sizes on each of the leaves represents the actual minified byte size of those individual files. So these numbers enable us to really get an idea of not only what is actually being included in the bundle, but more specifically, the weight of each of those files. Now, while you're free to do whatever you'd like with this data, I'm going to show you a new tool coming with Meteor 1.5, which makes it very easy to visualize this data. And that's the Meteor Bundle Visualizer package. I'll go ahead and Meteor add Bundle Visualizer. Hey, all right, so now we have this beautiful sundial graph. Now, this red ring in the center represents the entirety of the bundle. And that 3.32 megabytes in the center there matches up pretty closely with the 3.2 megabytes in the DevTools. And if we work our way out from that, we can see the various parts. We get more and more refined. So it looks like the Faker module is taking up quite a bit of space, 40% of the bundle. Let's go back and just remove that entirely. Awesome. Now, if I look at that center, I see it's gone down quite a bit, and the Faker is nowhere to be found. Highlight.js is taking up quite a bit of room too, so I'm going to remove that. And you know what? I'm pretty sure AWS SDK and ESLint aren't supposed to be in there either, and we know the direction this is going, so I'll get rid of those too. Okay, so that's quite a bit better. 518 kilobytes, and we can see that Lodash and some of the core modules are there, and we're okay with that. But one thing you'll notice here is that the bundle visualizer itself is actually taking up quite a bit of room. There's that D3 library. Now that makes sense because during the development of this visualizer tool, I chose to use D3 because D3 is fantastic for displaying data in this way. And it's a tool we use quite a bit at MDG on other products, but it is kind of a large project. D3 version 4 is actually quite a bit better than D3 version 3 because it supports modular imports, so you can get your project to be quite a bit smaller. But because this is a bundle analyzer, I definitely want to try to avoid having that reported in the stat. The bundle analyzer is a package after all, and therefore it's included in the initial client-side bundle. Luckily, this is Meteor 1.5, and we can take advantage of dynamic imports, which not only work at the top level of an application, but also in packages. I'll open the source code to the visualizer here and go to the main entry point within the package, which is client.js. We'll see there's the import of the sunburst, and the sunburst file has the D3 imports within it. If I change the static import to a dynamic import, the import will return a promise. The promise will be resolved when the import is ready to use and will then proceed with rendering the sunburst via the main method. And most importantly, the entirety of the sunburst import and all its child dependencies, including D3, will be excluded from the initial client bundle. And let's go back and take a look. Okay. So the bundle size has dropped again, and the D3 package is no longer showing up. Additionally, it's worth pointing out that dynamic imports are also cached on the client independently. So assuming that the package doesn't change, future loads of this page won't incur the round trip to the server to fetch the sunburst.js file, but rather fetch it from the local cache. I think that's it. Internally, we're excited that it's now easier than ever to analyze the contents of these client bundles. We have some pretty large projects using Meteor, and the larger they get, the easier it is for dependencies to get bulky. This makes it so anyone can easily do an analysis on what's taking up the space. In fact, within minutes of my initial testing of this visualizer on some projects at MDG, I found dependencies which were taking up a lot of space and even identified some which weren't supposed to be there at all. As a perfect candidate for becoming a dynamic import, highlight.js. We use it for providing syntax highlighting on GraphQL queries in our Apollo products. However, we only use it on certain pages, and it's not a tiny package by any means, so it's certainly not important to load it right away on every page. We look forward to speeding up some of our own initial page load times with enhancements just like this. I really hope you'll enjoy this utility. It's part of our goal for providing you better tools for deciding when JavaScript is loaded or executed. Again, the stats which this package uses are available within all Meteor 1.5 apps, whether you use the visualizer or not. As long as you use the minifier packages, specifically the standard minifier.js package, which you should be, you'll get the stats available in your bundle. We certainly encourage the community to iterate on this package via issues and pull requests, or if you have an idea for a completely different package, we hope you'll find the new data we've exposed helpful for making your own package and hopefully sharing it with the community. If you're interested in how this package works, as of a few hours ago, it has been published and you can find the commit for it on the Meteor 1.5 pull request, which is also a great place to provide feedback. That's the end of my demo. I hope you found it helpful. Sashko will take over from here, and I hope you all have a great night.
So basically, if you guys want to learn more about both Meteor 1.5 and in particular the bundle analysis stuff, like Jesse said, the pull request is the place to go. One of the reasons that we hadn't released Meteor 1.5 yet, but you see there's an RC today, is because we felt that people wouldn't get that much value out of it if they didn't have a tool to actually figure out if dynamic imports were working or if they were improving your app, right? Because you could spend a lot of time converting those imports to be dynamic and not really notice that much of a difference or not know which things you should be making dynamic or not. And as Jesse said, we found a lot of candidates in our apps, and some quite embarrassing things as well that we didn't even know we were importing. So Galaxy and optics are going to become a little bit faster as well from that. I want to take just 1 minute to talk about what might be happening beyond 1.5 in the Meteor project. So the first thing is Meteor 1.6, and some of these things are things that we initially wanted to get into 1.5, but we wanted to get this bundle size stuff and dynamic imports out as fast as possible. But soon afterwards, we're going to work on making the Meteor framework even more modern and lightweight, like you might expect in today's world. The first thing there, of course, is upgrading to Node 6, which actually brings a fair amount of performance improvements and also notably native promise support on your server, which can make your code a lot simpler and faster. We're hoping to remove a lot of the dependencies that we've depended on in the past. In particular, underscore is one of those things that we've still got, but you can easily use Meteor without jQuery now, but not yet without underscore. And also standardizing even more around promises and async await instead of, for example, fibers. So really, really excited for that. And even further, I mean, people have been asking, what is the context of Meteor in today's JavaScript ecosystem, right? Like, when Meteor started out, it was quite a different world than what it is today. And I want to leave you guys with this one sentence here, which is that the goal of Meteor is going to be to enable you to write your JavaScript code and not worry about anything else. So, for example, you might have noticed that to do dynamic imports in Meteor 1.5, you have to write exactly 0 configuration of any kind. You just start dynamically importing things, and it just works. And so expect more features like that that let you do cutting-edge JavaScript stuff without having to worry about how it works or having to set it up at all. And that's the presentation. Thank you.